Section 11.6, Solving Quadratic Equations by Factoring. The objectives: solve quadratic equations by factoring. The definition of a quadratic equation are equations that can be written in the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a is not equal to 0. A really important property is the zero factor property. The definition: if the product of two or more factors is 0, then at least one of the factors must be 0. That is, for real numbers a and b, if a times b equals 0, then a is equal to 0 and or b is equal to 0. You use the zero factor property in all math classes that are not theoretical. To solve a quadratic equation by factoring, step 1, add or subtract terms as necessary so that 0 is on one side of the equation and the equation is in the standard form ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a is not equal to 0. Step 2, factor completely. If there are any fractional coefficients, multiply each term by the least common denominator first so that all coefficients will be integers, then factor. Step 3, set each non-constant factor equal to 0 and solve each linear equation for the unknown. Step 4, check each solution one at a time in the original equation. Example 1. Solve x minus 5 times 2x minus 7 equals 0. Since the quadratic is already factored and the other side of the equation is 0, we use the zero factor property and set each factor equal to 0. This process yields two linear equations which then can be solved. X minus 5 equals 0 or 2x minus 7 equals 0. With x minus 5 equal to 0, we're going to add 5 to both sides, so x equals 5. With 2x minus 7 equals 0, we're going to add 7 to both sides, giving us 2x equals 7. Divide both sides by 2, x equals 7 halves. Thus, the two solutions, or roots, to the original equation are x equals 5 and x equals 7 halves. Or, we can say that the solution set is 7 halves 5 inside the squiggly brackets. The solutions can be checked by substituting them one at a time for x in the equation. That is, there will be two checks. Substituting x equals 5 gives the following. X minus 5 times 2x minus 7 is equal to 5 minus 5 times 2 times 5 minus 7, which is 0 times 3, which is 0. Substituting x equals 7 halves gives the following. X minus 5 times 2x minus 7 equals 7 halves minus 5 times 2 times 7 halves minus 7, which gives us negative 3 halves times 7 minus 7, which is negative 3 halves times 0, which is 0. Therefore, both 5 and 7 halves are solutions to the original equation. Example 2, solve by factoring. 3x squared equals 6x. The first solution step is going to be write the equation in standard form with 0 on one side by subtracting 6x from both sides. This gives us 3x squared minus 6x equals 0. Next, we're going to factor out the common monomial of 3x, or your GCF. 3x times the quantity x minus 2 equals 0. Now we're going to set each factor equal to 0. 3x equals 0, or x minus 2 equals 0. With 3x equals 0, our first thing is going to be divide both sides by 3, which gives us x equals 0. And on the right, we're going to add 2, which gives us x equals 2. The solutions are 0 and 2. Example 3, solve by factoring. X squared minus 8x plus 16 equals 0. The trinomial is a perfect square, so it factors into x minus 4, that quantity squared equals 0. This gives us two factors, both are the same. X minus 4 equals 0, or x minus 4 equals 0. We're going to add 4 to both sides, which gives us x equals 4, and this solution is repeated. So the only solution is 4, and it's called a double solution or a double root. Example 4, 4x squared minus 4x equals 24. We're going to add 24 to both sides. Add a negative 24 to both sides so that one side is equal to 0. 4x squared minus 4x equals 24, which gives us 4x squared minus 4x minus 24 equals 0. Same thing as subtracting 24 from both sides. We're going to factor out the common monomial of 4. That gives us 4 times the quantity x squared minus x minus 6 equals 0. Now we're going to factor x squared minus x minus 6, which is going to be 4 times the quantity x minus 3 times the quantity x plus 2 equals 0. The constant factor 4 is never going to be 0, so that's not going to affect our solution. The two equations we're going to look at are x minus 3 equals 0 or x plus 2 equals 0. X minus 3 equals 0, we're going to add 3 to both sides, gives us x equals 3. X plus 2 equals 0, we're going to subtract 2 from both sides, giving us x equals negative 2. The solutions are 3 and negative 2. Example 5, solve by factoring. We have the quantity x plus 5 squared equals 36. Don't get too excited and think it's already factored because you have the parentheses. Remember, you have to set it equal to 0 and then factor. So our very first step is going to be to go ahead and multiply out what's on the left. The x plus 5, that quantity squared, becomes x squared plus 10x plus 25 equals 36. Now we're going to add a negative 36 to both sides or subtract 36 from both sides. That's going to give us x squared plus 10x minus 11 equals 0. Now we're going to factor that quantity, x squared plus 10x minus 11. It's going to become x plus 11 times x minus 1 equals 0. So our two factors are x plus 11 equals 0 or x minus 1 equals 0. For the first factor, we're going to subtract 11 from both sides. That's going to give us x equals negative 11. For our second factor, x minus 1 equals 0, we're going to add 1 to both sides, giving us x equals 1. So our solutions are negative 11 and 1. Example 6, solve by factoring. We have 3x times the quantity x minus 1 equals 2 times the quantity 5 minus x. Our first step is going to be distribute on both sides. 3x times the quantity x minus 1 becomes 3x squared minus 3x. 2 times the quantity 5 minus x becomes 10 minus 2x. That leaves us 3x squared minus 3x equals 10 minus 2x. Now we're going to set it equal to 0. So we're going to subtract 10 and add 2x to both sides. That's going to give us 3x squared minus 3x plus 2x minus 10 equals 0. And we're going to collect like terms. That's going to give us 3x squared minus x minus 10 equals 0. We're going to factor that. That quantity becomes 3x plus 5 times the quantity x minus 2 equals 0. So our two factors are 3x plus 5 equals 0 or x minus 2 equals 0. For the first factor, we're going to subtract 5 from both sides, giving us 3x equals negative 5. We're going to divide both sides by 3, giving us x equals negative 5/3. The other factor, x minus 2 equals 0, we're going to add 2 to both sides, which is going to give us x equals 2. The solutions are negative 5/3 and 2.